secrets of Graphite Customs revealed.
Hey guys, it's Casey here with Graphite Customs. We're going to go over a mold here that is one of our production molds to see how we actually create them and machine them and get them programmed. So let's get started. First thing we have to do is define our material, so that's already defined. That's our basic shape for the gauge. The next thing we have to do is set up the material. So we're going to use 3/4 of an inch. So you can see here this purple area down here is actually the virtual material that we're going to cut into, so we can do a simulation later, make sure everything looks right. Next we're looking at the vectors here. So these are all their own vectors, circular. We laid those out earlier to get our design. We can make this whatever we'd like. So the next thing we have to do is an area clear. So this area clear is what we use to just get the rough material out, basically. So we're going down 3/8 of an inch, 0.375. We're going to leave 10 thousandths tolerance. So this allows us to have a little extra material on the sidewall for when we clean it up later. It just gives us a cleaner edge throughout. We have to add a tool. So the tool we're using today is an 1/8 inch 3-degree flat end mill. So I can click that, get that in there. We can look at all the parameters then of the tool. So first off, we have the step over, then the step down. So this is our depth of cut and our step over. So how much of the tool is cutting on the diameter. So a little over half on the step over. We're trying to rough, so we don't need to be real careful. 65 inches a minute, pretty quick, getting that material out of there. Plunge rate, and then we have the RPM and our tool number. Tool number is what we use for tool changing, so every tool is defined within our program. Next we're going to use an offset strategy. So this will follow the shape of the vector. It just gives you a cleaner, better cut. We're going to climb mill. Then we're going to do the start point inside. So if we go inside, that will be inside the vector rather than outside the vector. Next, we're going to look at the ramping moves. So this will just give us a cleaner entry into the cut so that we're not putting too much tool pressure on the tool or the piece in that initial plunge into the material. And lastly, we've got a machine safe height. So this is just where it goes from one side to the other, or one cut to the next, how high it goes above the material. So I'm going to hit calculate here. When we calculate this, you'll see all the tool paths show up in some red lines. Real quick, so you can see the red is our tool paths at the 65 inches a minute, and the blue is actually our entry. That's that ramping move that we set up earlier. So it'll go a little faster, but it's at a much smaller cut, and we can see that in the simulation. Next thing we're going to set up is the profile. So this profile will only go around the diameter on the inside. So this is just to clean up that extra 10 thousandths we left, and then it'll give us a nice clean cut in perfect circle when we're done. So we're doing the same depth, 375. Then we're doing the same tool, 1/8 inch, 3-degree flat. We use a 3-degree for the relief so that when you put glass or metal into a mold, it comes out really easily. But it's so small you don't really see the angle on it. The big difference here is we're doing the step down at a full 375. So that will go the full depth, one cut all the way around. And we're going at a smaller, slower feed rate of 40, and then the rest is all the same here. We can do some lead in or lead out, ramping moves, but we don't really need to do any of that. It's a pretty simple operation. Same safe as E as well. So when I hit calculate, take a look here right next to this line. You'll see another one pop up. There you go. See that? That's just a little extra 10 thousandths skim pass we're putting on the edge here. And it doesn't add a lot of time, but it does a lot for the process. So next we're going to simulate this. When we simulate it, then you can see exactly what the machine is going to do. So we'll do it in high detail. And you can see our tool kind of comes in as a line drawing, but you can see that 3 degrees on it as well, instead of just being a straight flat end mill. So when I hit play here, you'll see it start to go. And in the video, when we actually machine this, you'll see that it does the exact same operation. It does the same pattern. It's exactly what we're going to see in real life. So I'm going to speed this up. We don't need to watch each one. You can see all those tool paths coming through. the red pass that we calculated earlier. Perfect. Looking pretty good. So that's a good start for this. Next one we're going to do is the profile. We'll simulate that just to make sure it looks right. Again, same tool. And if you'll have to look real close. You can see it best on these bigger ones to see that material being removed. So you can see those holes getting opened up just a little bit, and it just cleans everything up to look real nice. So then we have a perfectly programmed gauge mold.
Sweet. So next we're going to head out to the shop. Safety first. You know, I say safety's sexy. All right, we're getting our gloves on. We got our mask on. We got our safety glasses. Here's the end mill we're going to be using. It's, again, that 3-degree flat end mill. We're going to clean out our taper here. We always try and clean these out. If they get too gaued up, they just won't work as well. They're not as accurate. We've got our collet, put it in the head there, the threaded head, and then we're going to just get this in here and tighten it down. This is something you don't have to like really torque down. We're just going to get it nice and snug and tight. If you torque it, you can mess it up and whatnot. We got a lot of leverage on that, so we got it nice and tight. So now we're here at the machine. Again, clean out that taper, both ends. Make sure there's no dust or anything left over. And the first thing we're going to do is measure this tool. So you can see here, we're going down to that touch off and getting perfect measurement. Now we're going to set up our material. So we got to get this nice and tight in the vise. So we hammer it down a little bit, make sure it's flat on those parallels. Then we're going to get our probe out. So this probe is really nice to have, so it's a quick operation to get it perfect on the corner. We don't have to do any edge finding. We can just bring this down. It'll find the edge for us, and then we can move from there. So now I always program from the center of the material just because it makes it cleaner. Nothing's offset. So next we have to move to the center, 0 on the center, and then we can 0 our z-axis height. This is another thing that can be probed, but it's just a little bit of a pain. So I just use a piece of paper, get it in there, move down real slow until it touches. I know that's the top of the surface, and then we can 0 on the top of the z. We got to turn our vac on. That's very important. We don't normally use blow air on these, but for these videos we do just so you can see what it's doing. So here we're going to start cutting. You can see it's doing the exact same movements as what we programmed. So we're going to go slow on this first one just so we can talk about what's going on. So you can see in the beginning it moves real quick, a few directions right at the center. So that's that lead-in movement that we had. So that gets us a nice easy cut on that end mill, so we're not screeching or making any big noises or messing up our end mill throughout it. There's a lot of things that it just helps to make it easier on the machine and everything. So we're getting down there, making a lot of dust. We got a good vac system on here, so we're catching most of it, but I do like to wear a respirator when I'm doing this type of stuff, just to be extra cautious. So we're getting to the bottom. I think this is our last cut here on this one. So we'll move to the next one, and then we're just going to do a quicker time lapse just so you can see that it's all getting done. So we're coming up on the end here, and what we're going to look for is just doing the finishing pass on the outside. So it's going to go back to that first hole, and it's going to do just a finishing pass all the way around. You can see that just taking off that 10,000ths that's left over, and that'll give us a perfect surface finish on the outside edge. Each hole gets it. Perfect. Turn off that vac system, and then here we are with the finished piece. Perfect. Thanks for watching, everyone. Make sure you visit our website and give us a like on Instagram, YouTube, everything. We'll be putting more videos out like this, more complicated, and I hope you enjoy it.